We are on lesson 4 of calculus with Larson. It's the beginning of the year, so we're reviewing precalculus from last year before we dig into our calculus. This is the section 4 of P.4, review of trigonometric functions. All right, so the first one here, we're going to change degrees to radians and radians to degrees. This is similar like the changing feet to inches. So like if you had 12 feet and you wanted to change it over to inches, you would convert it because 1 foot is 12 inches. So 12 times 12 will give you 144 inches. Likewise, pi is equal to 180 degrees. So our conversion on that is pi over 180. Okay, so doing the first one here, it's negative 20 degrees. So we don't want the word degrees. So we want to cancel that out and have pi. So you end up with then 20 over 180, or 2 over 18, which is negative 1/9 pi, or negative pi over 9. The directions also would like us to do it to 3 decimal places. So putting in our calculator here, secant pi divided by 9 gives you negative. You're going to have negative here we go. Negative 0.349. I can do this. All right, and then on the next one, it is 240 degrees. So again, we want to change that to radians. So you want to cancel out the degrees and have it in pi. 24 over 18, divide those both by 6, and you get 4/3 pi. And it's negative, so negative. And then changing that to degrees, 4 times pi, divide that by 3, and it's 4.189. You got to round that 9 up to 8 because they said the 3 places and the number after the 8 was 5 or more, so that takes that to a 9. And it's negative. Next up, negative 270 degrees. And again, you want to cancel out the degrees, and the zeros are gone. 27 and 18 both divide by 9, so that makes it 3 over 2 pi, negative 3 over 2 pi. And changing that to radians, 3 pi divided by 2, and you get 4.712. And it was negative, so put a negative on it. Okay, the last one, 144 degrees. So put the 180 there and the pi on top. I'm going to use my calculator to clean that one up. So 144 divided by 180, and then hit math, enter, enter, and it makes it 4/5. So 4/5 pi. And we could change that then to decimal, so times pi, so that's 2.513. All right, the next ones want us to do the same thing, but this time it's in radians, and they want us to change that back to degrees. So it's currently says 7 pi over 3, but we don't want it, there we go, 7 pi over 3. And again, we don't want it in radians, we want it in degrees. So cancel that out. So it's going to be 7/3 times 180, which gives you, 7 divided by 3 and times 180. It gives you 420. So 420 degrees, or what you could have done 3 into 180, 60 times 7 is 420. Okay, the next one, negative 11 pi over 30. So again, we want to lose the pi, have 180. 30 goes in 180 6 times, negative 11 makes negative 66 degrees. Then we have 11 pi over 6 for the next one. So for 11 pi over 6, again, we don't want the pi, so that's gone. And then 6 goes 180, 30 times 11 is 330 degrees. Again, you can use your calculator if you wanted, if you're not good at doing that. Last of all, we got 0.438, and again, it's in radians. Even though they don't say the word radians, it can be frustrating to people. If they say it's an angle and they don't have the word radians or the degree symbol on it, you have to assume it is in radians. So since it is in radians, we want to cancel out the radians and get it into degrees. So 438 times 180, and then divide that by pi. Gives you 25.096 degrees. All right, the next one down would like us to evaluate that trigonometric function. I like making a right angle out of it. I like a right triangle. We went over 8 and we went down -15. You need to know the third side of the triangle always to do the trig. So you're going to use the Pythagorean theorem to find that third missing side. So square the legs, and that equals the hypotenuse squared then. So you get 64 plus 225, which is 289, and then the square root of that is 17. Now I know it's plus or minus 17, but the radius is always going to be a positive number on these triangles, so it's a positive 17. And then using SOHCAHTOA, we got for the 6 functions sine, cosine, tangent, and for the other 6, flip them over. So the reciprocal of sine, 1 divided by sine, is cosecant. The reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. So SOHCAHTOA. So looking over here, the angle that we want, you always look at the center. When they're saying theta, angle theta, it's going to be the angle at the center of it. And so opposite from that is the -15, which is the y. The y, remember sine and cosine, cosine's x and sine is y when you're doing the points on the unit circle. So cosine's always x, are the adjacent side. So x are the adjacent sides 8. So adjacent x, hypotenuse is the y. Well, the hypotenuse is the radius. Sorry about that. The opposite side is the y. Opposite from that angle is the y. Adjacent to it is the x. So then this is x over r. And this one's y over x. And then for the reciprocals, just flip them over. All right. So again, from the top, you had to do the Pythagorean theorem to find the missing side. The y value is the opposite side. The x value is the adjacent side. And so from there, you can just fill everything in. So the y was -15 over the hypotenuse, or the radius, 17. 8 over 17, because x is 8. And then -15 over 8. And then just flip them all over. And just a side comment here about a negative. You can float a negative wherever you want on a fraction. You can put it on the top, you can put it on the bottom of the fraction, or if you want, put it in the middle of it. Wherever you float it in the front, the whole number is negative. It doesn't matter where you put it at, it's negative. Okay, on the next page, they have secant is 13/5. They say it's an acute triangle. It's an acute angle they set up here. So it's going to be in the first quadrant. And again, the theta is always here. Secant is 1 over cosine. So it's a reciprocal of cosine. Remember, cosine is adjacent over hypotenuse, or x over r. So this is going to be r over x when it's flipped over. So the radius here is 13. And the x value is going to be 5. And then doing the Pythagorean theorem, you get 5 squared plus, well, I don't know, we'll say b squared equals the hypotenuse 13 squared. So you get 25 and 169. Subtract, and that's 144. And then the square root of that is plus or minus 12. And it's going to be a positive 12 because it's in the first quadrant. So when you go up, the y value is positive. So they wanted to know all the other functions. So again, you got sine, cosine, tangent. The reciprocals, cosecant, secant, cotangent. They gave us secant, which is 13/5. We can just flip it over right now to 5/13. All right, sine is opposite, or the y value 12 over the radius 13. Flip it over. And then tangent is opposite, which is 12 over the adjacent 5. Or you could say the y value over the x value, and then flip it over for cotangent, or 5/12. right, on the next one, we are doing solving equations for trigonometric equations. You could factor on this one or take the square root of both sides. I am going to take the square root of both sides. So that would make tangent theta equal to plus or minus radical 3 over 2. The plus or minus radical 3. They wanted all the answers between 0 and 2 pi. This is where I know when your unit circle comes in handy. I got a copy of it here. All right, so where is tangent plus or minus radical 3? Remember, tangent is sine over cosine. So tangent here is radical 3 at 60 degrees. For the sine of radical 3 over 2 divided by the cosine of 1/2 gives you then radical 3. So at all the 60-degree angles, it is radical 3. And tangent is positive here. And tangent's also positive down here because two negatives make a positive, and you're dividing the sine and the cosine to get the function, and those are both negatives, so it makes it positive. So then tangent's negative here and here. And cosine and sine are both positive here, and they're both negative there because you look at the signs of the x and the y. All right, so they wanted to know all of them, and we had plus or minus radical 3. So that's going to be all the 60-degree angles. Pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. On the next page, they have a sine and a cosine here, and we're supposed to solve it. That's like having two different letters in the equation, like the letter x and the letter y. Remember, the goal is always to get it down to one letter to solve it, so we need to get it down to one variable, which I'm going to go for dividing it by the cosine. That way we've gotten rid of the word cosine, and that changes it then to tangent equals 1. Now we only have one letter or one word, just tangent. So we want to know where a tangent theta is equal to 1 at. And it's a positive one. Remember, I told you tangent is positive here and here. And it's sine divided by cosine. So radical 2 over 2 divided by radical 2 over 2 gives you the number 1. So it's going to be pi over 4 and 5 pi over 4, because that's where tangent's positive at. So pi over 4 and 5 pi over 4. Okay, on the next one, we're looking at sine cosine waves. All right, the basic function for sine cosine, you put an a in front of the function, and then the cosine of bx kind of is the basic of it. So a is the amplitude, and the b is the period on it. Well, it affects the period on it. We'll call it maybe the period change on it. All right, so cosine usually starts at, it starts at the number 1, it ends at the number 1, in between it's at -1, and in between those it goes to 0. So for the 4 tick marks, you're going to divide it into 4 for the basic function and graph it, makes it easiest. It goes 0, pi over 2 pi, 3 pi over 2, 2 pi. Again, cosine starts and ends at 1. In the middle it's -1. In the middle of those it's 0. All right, so the period here for cosine, it starts here on a high, and it's going to end over here on another high. And they counted by, let's see, here's pi, and then that's going to be 2 pi, because every 2 tick marks, so that's 2 pi. And then we got 3 pi, and then the next one over is going to be 4 pi. So it started up high and then hitting the tick marks here. The next one's going to hit right here. So the period of the whole thing is 4 pi. And the amplitude on it is going to be, instead of hitting at the number 1, it's hitting up here at the number 1.5. So the quick answer on what the amplitude is that it's 3 over 2. a longer answer on it, to find amplitude, you do the max minus the min and divide by 2. Here the max is 1.5. The minimum is down here at negative 1.5. And divide by 2. So you get 3 divided by 2, or 1.5. And then the b value, the period is definitely changed because it doesn't start and end. It's 0 and 2 pi. So it's longer than that. It started here at 0 and it ends at 4 pi. So what we're going to have to use is the formula to convert it on. Knowing that the period of sine and cosine is usually 2 pi, the b value changes it. And again, the period on this one was 4 pi. So I'm going to flip these, because you can do that when you solve for proportions. So b equals 2 pi over 4 pi. So you get b is equal to 1/2. Well, no, what did I do? So let's see, 2 pi, the period is 4 pi. And you flip it, so you get the period is 1/2. No, it's supposed to be 4 pi though. I did something wrong. Let me figure it out here. The period is 2 pi over b, and the period on this function was 4 pi. Oh, we're just trying to find the b value. All right, yeah, we did it right. So the b value is 1/2. But oh, I see what they were asking for on here is what the period of the function is. So I overachieved on us. I'm so sorry about that. All we had to say was that the period was 4 pi. They didn't even want the b value. I did too much work. So sorry for that. All right, onward. We're going to graph now. We're doing sine, and again, it helps to know what the basic sine function, sine wave is. So sine going between 1 and negative 1. Again, 4 tick marks, ending at 2 pi, and then counting by pi over 2. It starts at 0, ends at 0, in the middle at 0. In the middle of those, it's 1 and negative 1. So we got 0, pi over 2, pi, 3 pi over 2, and 2 pi. 0, 0, 0, and 1 and negative 1. All right, so this graph does not have a change in amplitude because there's no a value here, and it doesn't have a change in the period, so the period is still 2 pi. So we're still going to count by the tick marks of pi over 2 on it. But what we do have is a vertical shift of pi over 2 because it's plus pi over 2 inside with the x. So that makes it a horizontal shift. Left. You're going to go left because you always do the opposite. You always do the opposite on the x's. So we're going to go left pi over 2. And I just realized you might not have seen anything I just did up on the top. That's really a bummer. All right, so one more time from the top. The basic sine function starts at 0, it ends at 0, and in between at 0, it rises to 1 and goes down to negative 1. And so you need to have all these numbers memorized on it. All right, so we shifted all those numbers pi over 2 left. Then on top of that, it went 1 up because it's outside the x function. So that makes it a vertical shift up 1. All right, so I'm going to count up 1, 2, 3, 4. I'm going to make that the number 1. 1, 2, 3, 4. So there's 2. I'm going to still count by pi. I'm going to count by pi over 2. So this would be pi over 2, counting over 2 tick marks. Counting over 2 tick marks, that's negative pi over 2. 1, 2, 1, 2, 1, 2. So that'd be pi, 3 pi over 2, and there's 2 pi. So our 0, 0 point has shifted left pi over 2 and up 1. So left pi over 2 and up 1. Puts it right here. And then the next point over, which is usually at the number 1. So when we go over here, it's going to be at 2 instead. And the next one comes down to 0, so it's going to be back up here at 1. And then so on, just to finish it all up here. Or you could say it started at 0, it ends at 3 pi over 2 because it shifted to the left pi over 2 and it went up once instead of being at 0, so to fill them all in. So that's one way people do it. They have you eyeball it. Another way you can do it that I like doing, because it was plus pi over 2, all the x's were minus pi over 2. Because it's plus 1, all the y's are plus 1. So for all of these x's, you subtract pi over 2. So 0 minus pi over 2, pi over 2 minus pi over 2, and then that would make pi over 2, 2 pi. Let's see, then 3 pi over 2 minus, see, 2 would make that pi, and then last of all, you'd have 3 pi over 2. And then 1 plus 1 on all the y's, so 1, 2, 1, 0, 1. Is another way you could do it, and then you could graph all of those points. All right, on the last one down here, they would like us to find a, b, and c for the sine function. Again, recall that sine starts at 0, ends at 0, and so it looks like this, and between it's 1 and the negative 1. Okay, but the key is here it starts at a midline. So this is still starting and stopping like it should. But notice the wave flipped over. It doesn't go up first, it goes down. So it reflected over the x-axis. The period on it's changed. It should start and stop. It starts here, it ends here, the wave. It stops at pi, so the period has changed. And the amplitude is also changed because it's supposed to go up to a max and a min of 1 and negative 1. All right, so to find the amplitude again, I would eyeball it and say 1/2. But if you want to work it out again, max minus min divided by 2. The max is 1/2. The min's negative 1/2. And divided by 2 gives you 1 divided by 2, or 1/2. But then on top of that, we're going to put a negative on it because it reflected over it. So a is going to be negative 1/2. And then the b value is how the period changed, and it definitely did change because it's not ending at 2 pi. So again, use that formula for the period, which was 2 pi over b. And we have the period here as pi. So pi equals 2 pi over b. And I'm going to flip these because you can do that on a proportion. So b is equal to 2 pi divided by pi. So you get b is equal to 2 on that problem. Let's see. Turn the page, double check everything. Yes, we got everything right. All right. Well, I'll see you for the next one.